My name is Sandy. I am a product manager for Google Cloud Databases. And with me today, I have Ravi Murthy, Senior Director of Engineering for Databases at Google Cloud. And we're so excited to be joined by Kristofer, Executive Director, Head of Data Stores and BI Engineering of the CME Group. I'm going to kick us off today. We're going to have a really great session for you guys, starting with a quick introduction of AlloyDB. We launched AlloyDB at Google I/O last year, and it's been a really awesome journey since going to GA last December, and I'll talk about it, give you a quick intro again today. Then we're going to go see AlloyDB in action, talk to Kristofer about his experience at CME Group using AlloyDB, and then Ravi and I are going to dive under the hood. And then finally, we're going to talk about getting there, things like migrations, our partner programs, et cetera, and what's next, how you can get started, and some great other sessions for you to attend. There we go. OK, introducing AlloyDB, a Postgres-compatible database the way only Google can deliver it. OK. Before we jump into what AlloyDB is, I want to talk really briefly about why AlloyDB was built by Google. And that's because we've been seeing customers, as they migrate to the cloud, approach their legacy proprietary databases differently. For databases like Oracle, SQL Server, DB2, and more, we're not seeing as many customers want to do like-for-like migrations. Instead, they're using the excuse of moving to the cloud as an excuse to modernize their database estate and move to standardized open source solutions. And there's one database in particular that we see emerging above the rest, and that's Postgres. And so why are developers and enterprises actually choosing Postgres? We think there are a couple reasons why this is a really great ecosystem. It's open source, so you get all of the portability that you didn't have before, really simple license management, and it's super cost effective. It has rich functionality that can compete with a lot of great enterprise databases on the market, including an extensible architecture, that amazing ecosystem of extensions, and it's built to scale. And of course, it's proven across millions of users in almost every industry and has a really great, friendly community. At the same time, what we hear from customers is that sometimes those migrations can be hard, especially if you're replatforming from a commercial-grade database, but even sometimes if you're running open source Postgres at scale. And so some of the pain points we've heard at GCP for customers running Postgres are really around scale, performance, and availability. But as we talk to customers, they are also excited about new opportunities as they move to the cloud. Opportunities to ease their management overhead and to access to build new types of user experiences, like real-time operational insights or integrating more sophisticated AI/ML capabilities into their applications. And so to do that, we introduced AlloyDB, a new open source compatible database engine ready for top-tier relational database workloads. A lot of folks over the year, I guess, that we've been live have asked me, why did we name it AlloyDB? And it comes from chemistry, the idea that you take these two products, and when you put them together, when you take these two different elements and put them together, you make something stronger. And I think that's what we've done here with AlloyDB. You take Postgres compatibility, again, a database and ecosystem that we really love, and combine it with some of the best of Google, that infrastructure that helps us scale, offer better performance, and better availability. Some of the most exciting things about AlloyDB are its performance numbers. It is 4 times faster than standard Postgres for transactional workloads. And actually, that's measured on a 16 vCPU instance, as you can see here. On a 64, we actually see even more performance benefit because AlloyDB can really take advantage of those larger machine shapes. And this helps not just with your top-line performance, but it can help with things like price performance as well, because sometimes you can run workloads using your AlloyDB instance on smaller amounts of resources. And it's up to 100 times faster for analytical queries than standard Postgres. Here's an example of a query that on Postgres takes over a minute to run, and on AlloyDB takes less than a second. So when we have this type of huge performance benefit on analytical queries, that doesn't just change your application performance, it changes the types of queries you can run, because the reality is you're never running a query in your application that takes a minute. But half a second, you can build experiences on that. Okay, so just to recap, AlloyDB was meant to deliver a commercial-grade experience without the costs and without the vendor lock-in. In addition to some of these performance benefits, and I'm going to talk about that last one, the replica lag, in a little bit, it's also highly available with a 4 nines SLA inclusive of maintenance, highly scalable with scale-out storage, horizontal scaling of reads, and vertical scaling of writes, and it's intelligent with autopilot capabilities and embedded AI ML to make management easy, but also with some tools and capabilities that allow you to build generative AI applications on top of it. And of course, it's fully Postgres compatible, making it easy to move to, easy to run. You can really, truly treat it like Postgres. And it has predictable, transparent pricing. And with that, I'm going to transfer over to Kristofer to talk about his experience at CME.
Thank you, Sandy. And thank you for inviting me to this conversation today. And thank everybody for joining. I know I've looked at this list of sessions here at Next, and they're all fantastic. And so you've chosen to spend your time with us, and thank you for that. So just a quick introduction to the Chicago Mercantile Exchange. Chicago Mercantile Exchange, or CME, was formed in 1898 as the Butter and Egg Board. It expanded over the preceding decades to include a number of additional agricultural products. And by the 1970s, the CME had revolutionized markets by providing futures against interest rates and other financial elements. And so with that, let's talk about our journey at CME to the cloud, and in particular to GCP, and the important role that AlloyDB plays in our transformation. Apologies. Okay, so we have a clear vision of what we're trying to achieve. And that's really providing modern analytics and truly great data experiences internally into our customers. But that presents a couple of different challenges for us. The CME, over the years, has modernized its technology stack several times. First starting with a legacy monolithic architecture, and then moving into more of a distributed systems to take advantage of new components and new architectures to enhance our systems. Well, now we're making an equally significant change here at the CME, which is adopting cloud, and adopting cloud specifically to provide us the velocity that we're looking for, that we need, that our customers need to bring those really great data experiences. Well, there are some challenges there, and one of those is, as part of the transformation to distributed computing inside of the CME has leveraged proprietary, vertically integrated database technology in order to achieve the velocity in our database subsystems that the markets demand. And I'll just go ahead and say it, that proprietary integrated database technology is Oracle Exadata. We also are working closely with our partners at Google to address some of the unique requirements that the financial services industry and our markets have. You know, it's all great to move to the cloud, but we have to ensure and create the guardrails necessary to keep our data and our customers' data confidential and secure. And then finally, there's one other challenge that we have in the database space, and that's our people and our processes. Our application developer community have been working with tools like pipelines, continuous integration, continuous deployment for a while now. But our database engineering and our database administration teams, because of the nature of the technology that we've been working with, haven't always gotten into that space. And so as part of this, we are upskilling our database engineering teams to be more in line with a cloud-based and DevOps culture. So one of these challenges that we have is that the Oracle Exadata platform provides a very high level of performance. And we need to understand, before we start architecting the processes and actually migrating our database applications to the cloud, we have to understand fundamentally first, is this going to accommodate our needs? Will it be performant enough and support the latency requirements and the throughput requirements that we have supporting our applications today? And so in order to accomplish that, we developed in-house a database testing and benchmarking framework. Now it is, I would say, inspired by an Oracle feature called real application testing, but we've baked in the flexibility to enable us to run benchmarks, to run functionality tests against various other platforms and compare those back to our legacy database infrastructure. And we've done this against a number of key critical workloads within the firm. The workload that I'd like to highlight for you today, in particular, is a clearing system. It's a critical clearing system involved in the clearing process. And one of the reasons that I want to highlight this for you today is because it illustrates also an impact of having leveraged these proprietary database platforms like Exadata. And that's that we have a hybrid workload here. We're not just tuning for fast transactions and OLTP usage, we also have analytical queries that the users can execute against the system through the user interface. And so this presents a particular challenge when we're trying to find and leverage fit-for-purpose database platforms in the cloud. And let me just let the cat out of the bag a little bit early here. The AlloyDB tests were fantastic. In our particular proof of concept that we did against this clearing system, AlloyDB performed very well against the transactional queries, our OLTP use case. In many cases, it performed better. And even with the analytical queries that we run against the system, we found that many of them are keeping up with the demands of the application. There are a few exceptions, and we'll talk about those. All right, now to kind of get into the details of the performance benchmarking that we've done for AlloyDB. So this represents one of our replays that we're using our in-house tool to effectively simulate real production workload that we pulled off of one of the live production systems. And in virtually every case, we found AlloyDB is meeting the transactional requirements of our application. There were a few exceptions. Those are those 197 OLAP UI queries that did take longer on AlloyDB. But I think that this just underscores the necessity of good design when you're working with relational databases. In this particular case, the application would allow the user to pick an arbitrary number of columns and apply an arbitrary number of filters to get the answer that they're looking for. And I'm sure there are database administrators out here in the crowd, and as you may know, that's a very, very difficult problem to solve for. And now let's talk about some of the outcomes, some of the learnings that we had through these performance tests and stress tests against the AlloyDB instances. One of the first things that I want to mention here This is just something that occurred to me a while back. I love Google's approach to database engineering in the cloud. As Sandy mentioned, Postgres is emerging for a number of reasons as the open source database of choice for Google Cloud, for many cloud providers, due to its flexibility, its license strategy, feature parity with Oracle in many cases. And so what Google's doing here is they're engineering fit-for-purpose services. So you may start with something like Cloud SQL Postgres. It's great for mid-range workloads. It's very cost-effective. And then you may reach a point where you just simply need a higher level of performance, a lower latency out of your database operations, or possibly a higher level of availability. And then Cloud Spanner is there to support your geo-distributed workloads. But the point that I'm making here is that from the outside, they all taste like Postgres. And so that enables you to use a common set of drivers, a common SQL language and dialect, and also a common set of tools against a very wide array of use cases, AlloyDB being one of those. Another key finding that we have here is we found 80%, actually more than 80% of our workloads don't actually require the level of response time, the performance that's offered by the Oracle Exadata platform. I think consolidation is natural, it makes sense. And when you buy into a technology like Oracle Exadata for a few of your workloads, it's only very natural to use the rest of your capacity, to consolidate onto that. And that has an effect unto itself, and that's that it creates a very tightly coupled data layer that we're now working to unravel here at the CME. A few other quick points. Because of the architecture of Postgres and Alloy by proxy, you may be allocating more sessions in your application to take advantage of things like read pools, where you can horizontally scale your reads across a pool of replicas while isolating your read-write primary. So that may require some additional sessions in your application layer to accommodate that, but generally speaking, it's well worth it. The other thing that I'll mention is that if you're looking at your database transactions at an atomic level, you may need a bit more CPU. That's fine in most cases. And then finally, many of us have worked on cloud-based databases before, and you know you're trying to achieve a particular level of IOPS in order to support your workload. Well, with many cloud providers, that has an effect, and that effect is you're over-allocating storage. You know, on one hand, as a database administrator, it's great. I'm never going to run out of storage, but there's a real cost associated with that. And so that's one of the patterns that AlloyDB here is working to break, is that no longer are we required to allocate orders of magnitude more storage than we require for a particular workload just to achieve our IOP target. And then now I'm going to pass the mic over to Ravi here, who's going to get into the guts of AlloyDB and talk about some of the features.
Thank you, Kristofer. So now let's look at a little bit behind the scenes of what is actually driving the kind of performance and the amazing things that Sandy spoke about. So Sandy and I will do a little peek under the hood.
Yeah, let's do it.
All right. The fundamental principle that AlloyDB is built on is this notion of disaggregation of compute and storage. So you've got the database layer. That's a set of compute nodes, and they're all talking to a storage layer that is disaggregated completely. So what disaggregation means is now you can scale the database layer completely independent of the storage nodes. And the storage nodes are able to balance the load and give you a very cost-effective and a very predictable performance. So the key point here is, thanks to this complete disaggregation architecture, each of the layers can scale very independently based on your workload.
And so jumping into the storage layer, what's really cool about this is that we have an intelligent database storage designed and optimized for Postgres. As you can see here, it's a regional storage service spanning multiple zones, and as Ravi mentioned, it's disaggregated itself. So you have compute resources in the storage layer completely separate from durable storage, which is based on Google's distributed file system, Colossus. When we talked about some of those performance benefits at the beginning, especially that 4x write throughput, the 4x transactional performance, a lot of that is driven by this storage architecture, because you have an architecture that powers fast, predictable performance, eliminating I/O bottlenecks, and offloading work from the primary to the storage service. It can also help with things like availability and read replica lag, which Ravi's going to talk about right now.
All right. So one of the things that the storage engine architecture gives you is the ability for many read instances to attach to the same exact storage engine. So AlloyDB supports the concept of read pools, which is the notion of a single reader endpoint behind which you can have even up to 20 read instances. And what this endpoint gives you is a very easy way to do horizontal scaling of your read connections. So as Kristofer was talking about, based on the workload, you can add new read instances very easily and very cheaply without doing any data copy. So you've got the ability to dynamically adapt your cluster and the amount of compute based on your workload.
And that's both up and down. So you can, for price
spin
performance.
it up.
Yeah.
And when you don't need it, very easy to spin it down. The other thing that read pools give you is this ability to handle your read workloads without having any impact on the primary. So you get complete isolation between your read workloads and your primary transaction workload. Also, these replicas and read instances are typically very low lag. What it means is it's tracking almost in real time what the view of the primary instance is. And typically, we look at something in the small single-digit millisecond lag. And this is something that we've taken even further recently with a bunch of innovations that we've done in the way the logs are transported and applied on the replica that results in an even lower lag. And the point of this low lag replicas is now it really opens up the door for a wide variety of reporting, analytics use cases that was much, much harder to do before this.
Definitely.
So let's actually look at some numbers. And here you've got two benchmarks that we're showing here. And it shows how AlloyDB compares to stock Postgres. So on the left, we've got a workload, which is a high transaction throughput workload running on the primary, but the read replica is idle. And in this particular case, the replica lag with AlloyDB is 25 times lower compared to stock Postgres. On the right hand is even more interesting use case, where in addition to the high throughput transaction workload on the primary, you also have a read workload happening on the replica. In this particular case, stock Postgres many times ends up with unbounded lag, just simply because the replica is not able to keep up with the primary. But what we've done in AlloyDB, thanks to a bunch of really clever innovations, is you always have bounded lag. And that's really awesome, as you can see here.
Yeah. I mean, like, the point of read replicas, right, is to do reads on them. And so what's really cool about this is it allows you to use all of your resources to the max while still keeping your replica lag in very manageable levels. One of my favorite features about AlloyDB is the super fast failover. We thought really hard about how to make AlloyDB a highly available service, and that means high availability for both unplanned and planned types of downtime that we take. So in the unplanned case, AlloyDB has very fast, bounded failover that's independent of database size and load, and of course an RPO of 0. That means no data loss on failover. You can see a quick diagram of how it works here with a primary and a failover replica and a single read-write IP. That way you're not having to manage multiple different IPs. You'll use the same endpoint to connect to the failover in the case where you have to. What I'm really excited about is we recently launched, actually thanks to feedback from CME, a new fault injection API for HA testing. So you can make sure through testing that your application failover is as smooth as your database failover is with AlloyDB.
That is really cool.
Yeah. And then finally, we wanted to make maintenance easy. Again, one of the most common sources of downtime is actually the downtime that we plan for, both us at Google when we do Google-initiated maintenance, and you guys when you do things like instance resizes or sometimes change flags that require a restart. With AlloyDB, our goal is to make these non-disruptive operations. And so we have, in addition to our primary, when we're doing maintenance, we're going to spin up a replacement primary in the same zone and maintain the replacement primary, and then coordinate a handoff from storage, after which the replacement primary becomes your new primary. Again, a really new feature we launched recently is now this happens with less than 1 second of downtime for most workloads on the primary, and again, 0 seconds of downtime on the read replicas. That means you're able to reconnect right away, a huge improvement from just a year ago when we were at 10 seconds.
Exactly. So this really makes this truly zero downtime extremely highly available, and you can use it for the most mission critical of your applications.
Yeah.
All right, switching a little bit from the database storage layer up into the compute.
Yeah.
When you see the architecture here, what you see is that the database layer is really a highly optimized Postgres engine with built-in tiers of caching, including RAM, memory-based caching, as well as an ultra-fast cache that we use for extremely low latency of data access. Now, in addition to the standard row-based caching that Postgres comes with, AlloyDB has also introduced a new column-oriented format, and I'll talk a little bit about that in a second. And the point is, both of these types of formats are automatically and dynamically handled by the database. No need for any application changes, and the database just figures out exactly what's the right format for the data based on your workload and puts it into the appropriate tier of the cache. So everything is automatic, and you get the transparent benefits of this. So what is columnar good for? It turns out it's actually really, really good for certain classes of analytical reporting type of queries that have to scan a lot of data. So what we've done in AlloyDB is introduced this new columnar engine that sits alongside the row-based engine of Postgres and does the right thing transparently. So based on the workload, it converts the data into the columnar format, and the columnar engine works on it using a highly state-of-the-art, if I will, type of an engine, using things like vectorized execution, Bloom filters, and a number of other techniques to have the highest possible performance that you can get with that type of query processing. So we support vectorized execution of things like filters and aggregates. And now recently, we've also added vectorized joins, which now opens up to another large class of workloads that can be handled by the columnar engine. We're also spilling it out into the ultra-fast cache, so you can handle much larger data set sizes. And last but not the least, we're constantly adding support for more data types in the columnar engine based on a lot of feedback that we get from our early customers. And the result of all of this is, depending on your workload, you can get 1-2 orders of magnitude higher performance with the columnar engine.
Awesome.
Switching gears a little bit, I want to very briefly touch on a set of features that we call the autopilot. And this is based on our thing of how do we make AlloyDB very, very easy to manage, very easy to operate. And so there's a set of features under the autopilot umbrella, and I'm just going to talk about 3 very briefly. So the first autopilot feature that I want to talk about is this thing called the index advisor. So as the name suggests, what it's doing is, based on your workload, it can give you a set of recommendations of what is the best set of indexes for your workload. It uses state-of-the-art AI/ML techniques to do this with very, very low impact on your system in terms of both storage and CPU. And the result, we have done a lot of benchmarking on a wide variety of workloads. Obviously, your mileage will vary depending on your workload, but on the thing that you see here, which is a real-world customer workload, the index advisor recommended indexes that give you a 4x better query performance. Now, of course, with indexes, you also have to worry about the DML performance and the cost of maintaining those indexes, but it's one of those things that can really make your job of operating these large databases with a lot of tables, a lot of queries, and things that keep changing all the time. Just let the machine tell you how best to optimize it.
What's really cool about this one for me is that it's columnar aware, which means that it helps you leverage these different features for speeding up queries in the way that's best for your workload. And again, in all cases, no schema changes.
Exactly,
Yeah.
exactly. Another quick autopilot feature that I want to talk about is on memory management. This is something that all database administrators really know, that one of the things that you really have to tune is how much memory you give to the buffer cache of the database. And there's a problem that if you don't get it exactly right, either you end up with out-of-memory errors, which have to restart the database, or you end up leaving performance on the table. So what we've done with AlloyDB is to say, OK, let the system figure it out. So we've got this thing called the adaptive memory management that based on the workload, current workload at that moment in time, it's dynamically able to use more memory or less memory. But what it guarantees is that you will not run into out-of-memory errors. So it's able to monitor how much memory each of the backends is taking, and it'll make sure that one bad backend or a misbehaving backend is not going to bring down your entire database. And that's a huge, valuable addition for folks who have to operate this database and ensure the highest level of availability. And last but not the least, another autopilot feature that we have worked on is this thing called adaptive vacuum management. Vacuuming is a very common problem that many Postgres folks who are familiar know exactly what I'm talking about. And not getting it right can have a disastrous consequence. The database can really be down hard. But what we've done with AlloyDB, again, in the spirit of autopilot and auto managing, have done this thing called adaptive and automatic vacuum management that guarantees that you just can not stop worrying about it, and the database automatically figures out how much resources to give to vacuuming to ensure that you won't run into transaction ID exhaustion, and if need be, it adds more resources for vacuuming and throttles back the transaction ID consumption. So lots more will go into this autopilot umbrella, but this is on our path of just making AlloyDB completely automatic and completely hands-off driving, if you will.
And again, when we talk about these autopilot features, it's really easy to focus out, oh, it makes management easy. But actually, when we look at things that customers really care about, availability, performance, it can have a huge impact. One of the largest sources of downtime for customers running Postgres on GCP are out-of-disk errors and out-of-memory errors. And so with the automated memory management, you're going to avoid those, even though we all hope that we can do it ourselves.
Sleep a little better.
It's huge. And then, storage scales up automatically, and drop a table, scales right back down. Okay, so we talked a little bit about these autopilot features, the way that we use AI and other adaptive algorithms to make management of the database easy for you. But we know that you guys are also hoping to use AI to build more interesting interactive experiences with your customers. And so today in the keynote, Brad announced AlloyDB AI. It's an integrated collection of features meant to help you as developers better integrate AI into your applications and leverage your real-time operational data to work with LLMs and build cooler experiences. That includes 3 parts. The first is high-performance, high-scale vector queries. A couple months ago, we launched support for the PG vector extension, and now we're introducing 10 times faster vector queries and support for 4 times larger vector dimensions. Again, to support a wider array of workloads, but to also make sure that we can meet your performance needs. That's due to tight integrations with AlloyDB's query processing engine. We also offer easy embeddings generation. AlloyDB allows you to bring your own embeddings if you would like to and generate them wherever you are. But if you're just getting started with vector embeddings, we also have a nice, easy function for you to create embeddings in the database itself based on your operational data. And finally, we offer integration with AI tools that includes open source tools like LangChain via the Postgres connector. It also includes integrations with Vertex AI. If you were here in this last talk, they just introduced Vertex AI extensions. We're super excited about that and looking forward to integrating AlloyDB. And then finally, this is a feature we actually launched, I think last year, but the ability to call a Vertex AI model directly from the database.
That's
really
a super
cool
powerful
Yeah.
feature. So you can call any model
Yeah.
that's hosted in Vertex AI right from inside the database.
Pre-trained models or custom models, yeah.
Amazing.
Cool. Okay, I'm going to talk about getting there. So I'm going to zoom quickly so that we have time for Q&A. But thank you so much, Ravi. I'm going to talk about getting there and how we can help you get from wherever you are to AlloyDB. So again, our investment in Google Cloud is to make database migrations easier than ever. And one of the ways we do that is via our database migration service, which now makes homogeneous migrations from Postgres, wherever you're running it, to AlloyDB easier and faster. But we've also introduced database migration service to support Oracle to Postgres migrations. Today that's available on Cloud SQL, but coming very soon to AlloyDB. And again, if you were at the keynote this morning, you saw one of our really cool new features, the ability to leverage Duet AI to do code conversion to help with the last mile of that migration. And then finally, we have an amazing program with partners if you're looking for folks to help you along the way. There are certified solutions and certified partners that know how to work with AlloyDB that can make your journey easier. And so we have a lot of the tools, but I actually wanted to bring Kristofer back on stage to talk about his experience and what he used. Actually, I'll drive for you.
Thank you, Sammy. Hello again. So earlier I talked about our first problem, which is there a cloud-based database that can keep up with our transactional throughput and latency requirements to support the exchange? The second problem is, how do we get there at scale? And so what we have internally is a program we refer to as the DB Refactory. And it's designed to solve a couple of problems. One is our app dev community, they're very busy, they have full backlogs, they're engineering features that the exchange needs. And so working our way into a backlog to say, hey folks, let's pause for a second and refactor your entire application for a new database platform, that's a tall order. And so with this DB Refactory program, we do a couple of things. We start with schema conversion and embedded database object conversion. We use a couple of tools.